Oh, the intro's done. Hello, I go by Aspen, and I've recently discovered something big in regards to the little-researched Bathypelagic sea serpent. I have deciphered the patterns behind their bioluminescence, and have discovered a language. Bathypelagic sea serpents, as their name suggests, live in the bathypelagic zone of the ocean, otherwise known as the Midnight Zone. Adult bathypelagic sea serpents can be anywhere from 25 to 40 meters long, the longest of the three types of sea serpent. However, unlike other sea serpents, bathypelagic sea serpents swim upright, with their head at the bottom and their body extending up. They rarely actively swim once adults, instead choosing to drift and grab passing fish with their arms. Another big difference between bathypelagic sea serpents and the other two types is their 8 skin flaps, a jellyfish-like adaptation that allows them to float, capture prey, and harbor symbiotes. Hidden by the outer skin of the bathypelagic sea serpent, colonies of a peculiar fish species circle, scanning for threats and prey through the gaps in transparency of the outer skin. When one spots something, it taps against one of the inner arms of the sea serpent in a pattern that indicates what it saw, alerting the serpent so that it can take action. You see, bathypelagic sea serpents don't actually have ways of detecting nearby life forms any further up from its face, where its 2 eyes, sensitive exclusively to blue light, sit. In exchange for this alert, the inside fish eat parts of the prey they help catch. Over generations, this symbiosis, a mutualistic relationship, has developed, syncing the reproduction cycles of the two species so that young sea serpents often have their very own colonies of inside fish. These fish have much more advanced eyes, sensitive to UV, green, red, and blue. Probably the most striking feature of the bathypelagic sea serpent is its bioluminescence, supplied by bacteria living within its transparent outer skin. The serpent can send signals that control this bioluminescence color and brightness. The sea serpents distinguish between 5 brightnesses: off, dim, faint, moderate, and bright, and 7 colors: violet, navy, cerulean, cyan, lime, green, and red. Affecting this, the bathypelagic sea serpent can spread red or black pigment on the inside of their outer skin, changing its color. Using this bioluminescence, the bathypelagic sea serpent can communicate with both the inside fish and other bathypelagic sea serpents. Due to the fact that the serpents, when teaching their young, have to indicate to the inside fish that the words displayed are for the purpose of education, the language changes with every generation. Thus, I will only be sharing the language of one specific sea serpent. And from what I can tell from poring over the footage, words take into account background color, the transition into the word, the pattern, the color, the brightness, and the duration. Additionally, the part of speech is determined by the transition out of the prior word. The exception to this is the very first word, which is understood to be a transition specifier without the need for a prior transition. We've already established the various different background colors, bioluminescence colors, and brightnesses, but the others have yet to be explored. There are 6 unique transitions and 4 unique patterns, now shown on the screen in each combination with bright red and dim navy. The durations are as follows: extremely short, which is 1 second, very short, or 1 1/3 seconds, short, 1 2/3 seconds, medium, for 2 seconds, long, 3 seconds, very long, for 3 1/3 seconds, and extremely long, for 5 seconds. Which transitions mean what part of speech is on screen now. All of these factors combine to make unique words. Generally, there aren't really any patterns when certain pieces mean certain things, but it should be noted that dim lights are usually later, deeper, and the top of things, bright lights are usually earlier, higher, and the bottoms of things, red lights are close, and blue lights are far. Finally, the transitions between words are colored, so that they're the first color on this list not used in the words on either side. All sentences in the language of the bathypelagic sea serpent begin with an indirect object. From there, the word order is OVS, object, verb, then subject. If there isn't an indirect object, you restructure the sentence until there is. For instance, I eat would be more like I feed food to myself, or more accurately, Aspen feeds food to Aspen because there aren't pronouns. Other words such as audience, all, or many can be used in place of you if there's a group of people in the audience, and if there's only one, you just use names. Descriptor words are inserted in the middle of words, splitting the word they're describing in half, with the first half of the duration before the descriptor, then the transition into the descriptor, then the descriptor itself, then the transition back into the described word, ending with the rest of the duration of the described word. Descriptors can describe descriptors with the same process, or there can just be multiple descriptors in between the two halves of the words. When words are split with the transition specifier approximately meaning is the same as, you can impart the meaning of one part of speech onto another part of speech. So if, say, you want to make an object out of a verb, you would first say the object version of the word, then split it with a transition specifier, and then have the other half be marked as a verb. Speaking of half words, another form of word splitting is in fact by width instead of length. I've called these words partial words, and they take the place of possessives or part-whole relationships. The word on our left is the possessor or the whole, and the word on our right is the possessed or part. These partial words are offset a little bit so that there's a bit of each word individually on either end of the combined words, with a minimum of 1/3 of a second, but maintaining the same duration, so that the end of whichever is longer by 1/3 of a second less than the actual length difference. For the remainder of this video, I will show you an example of this unique language.